In this video, let's talk about atoms and their subatomic particles. To start with, atoms are really very small. To give a perspective on this, if you had to keep 500 lakh atoms in a single line, that is this many atoms, if you had to keep it in a single row, then that would still only measure just 1 centimeter. 1 centimeter. So this is to show that the atoms are really very small. Now atoms, a bunch of atoms can combine together to form molecules. A bunch of atoms can combine to form molecules. Another interesting thing is that most of the space in an atom is actually empty. Most of the space in an atom is actually empty, as we usually measure the space between the central nucleus and the outermost orbital containing electrons. This is the space. This is the space. And if this atom has this as its valence or outermost shell, this space is mostly empty. This space is mostly empty. Okay. Now all the atoms contain 3 subatomic particles. They contain 3 subatomic particles. First one are called the protons. Next we have the neutrons. Then we have the electrons. Okay, let's look at the charge first. So protons are positively charged particles. They have a net charge of +1. They have a net charge of +1. Neutrons are neutral in general and they don't have a charge on them. Electrons, on the other hand, have a net charge of -1 and are negatively charged particles. Okay, so protons and neutrons together are located in the central nucleus, while the electrons move around the nucleus in distinct shells. They move around the nucleus in distinct shells. So if you look at the general structure of an atom, let's take for helium, whose atomic number is 2, or Z. So Z is the atomic number and also gives information on the total number of electrons. So it has a central nucleus containing 2 protons and 2 neutrons, and then we have a shell that contains 2 electrons, Okay, so this is how we show it. This is the central nucleus that contains the protons and neutrons, and then we have a shell around the atom, around the nucleus, in which the electrons revolve. Now these 2 electrons keep circling around the nucleus in this first shell. Now if an atom has more electrons, accordingly you can have more shells to accommodate more electrons. It is important to remember that each shell can only hold a distinct number of electrons. Each shell can only hold a distinct number of electrons. So this is with respect to the charge on the subatomic particles. Now let's move to the mass of the subatomic particles. The mass of an atom is usually measured in atomic mass units, or AMU. The mass of an atom is measured in atomic mass units. So AMU is defined as 1/12 the mass of carbon 12, which is the most common isotope of carbon. So AMU is defined as 1/12 the mass of an atom of C12. Now this has a weight of 12 AMU. So carbon atom has a weight of 12 atomic mass units, and this is taken as the reference for all the other atoms. So protons and neutrons each have a relative mass of 1 AMU. Protons and neutrons both have a relative mass of 1 AMU. Okay, compared to this, the mass of electrons is highly negligible. The mass of electrons is highly negligible. In fact, it is around 2000 times less than the charge of a proton or a neutron. So this tells us that the mass of an atom is almost entirely concentrated in its nucleus, because that is where you find the protons and the neutrons. The mass of an electron is very negligible in comparison with that of protons and neutrons. So to summarize the whole video, let's look at this table. So we have 3 subatomic particles, which are protons, neutrons, and electrons. Protons have a positive charge. They have a charge of +1. They are located in the nucleus, and their mass is equal to 1 atomic mass unit. Next, we have the neutrons, and as the name suggests, they are neutral and don't carry any charge. They are also located in the nucleus along with the protons, and even the neutrons have a mass that is equal to 1 AMU. 1 AMU or 1 Dalton. Both of them mean the same. So the mass of a proton or a neutron can also be given in terms of Daltons, and it is 1 Dalton. Finally, we have the electrons. The electrons have a net negative charge. They are negatively charged. They are present in shells around the central nucleus in orbitals. The electrons are present in orbitals, and it's important to note that each orbital can only hold a finite number of electrons. The electrons don't contribute much to the element's overall atomic mass, and hence they have a mass equal to 0. They have a mass equal to 0. So in a neutral uncharged atom, the total number of electrons is always equal to the total number of protons inside the nucleus. So in these cases, the positive and the negative charges cancel each other out, leading to the atom with no net charge.